So today we're going to start Unit 4, and Unit 4 starts our unit on exponents and exponential functions. All right? So before I'm going to be conscious of all my filler words now. So in order to do anything with exponential functions, we first have to learn about exponent rules. So we're going to spend a lot of time today learning about exponent rules. And we got to learn a little bit of terminology. The first one we're going to talk about is something called a monomial. Say monomial. Monomial. Now, mono, the prefix mono on a term usually means one, right? Right? So if you're in a monogamous relationship, that means you only have one significant other, right? 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 If you're polygamous, that means you might be married to, or you might be married or dating other people. Who knows? All right. So, yes, mono means one. Okay? So a monomial is a polynomial that only has one term. Okay? It is made up of products. What is a product in math class? Anything multiplied together. So it's made up of products of numbers and variables. All right? It can be just a number or just variables, or it could be a product, all multiplication of numbers and variables and their exponents. All right, so these are all examples of monomials. 5 is just a constant term. It's a monomial. Y'all know just a number is called a constant, right? Okay, no variables. So a constant is a monomial. 2 times x is just a monomial. 15xy cubed is a monomial because all you see is multiplication happening. There's no pluses and minuses, no dividing. And m is a monomial. Okay? So the only operation you see in a monomial is multiplication. There's no pluses, no minuses. Okay? All right, monomials that have the same variables with the same exponents, I'll have y'all frozen, are called like terms. Okay? So when we add or subtract monomials, we call that combining like terms. And we've done that before, haven't we? Yeah, we know all about combining like terms. So adding or subtracting monomials, we're going to combine like terms. To add or subtract monomials, you're going to combine like terms. And we know from way back when that like terms are when you have the same variable with the same exponents, right? So like an x squared and an x, are they like terms? Is an x squared and an x like terms? No, because they don't have the same exponents, right? So an x squared is only like terms with an x squared, and an x is only like terms with an x, and constants are like terms with constants, right? Okay, so we're going to just practice combining some like terms, also known as adding and subtracting monomials. Yeah, it's easy to think about. Y'all be careful bumping the wall back there. 17x minus 25x. Now, are these monomials like terms? Yeah, they both just have an x, right? So when I combine like terms, I just add and subtract the coefficients. So that's a positive 17 minus 25. What is positive 17 minus 25? Negative 8. And when you combine like terms, you leave your variable just like it is. You don't change your variables. You don't put a square on it when you're adding and subtracting. You just combine your like terms and keep it the same variable. We good? Number 2 says negative 23y squared plus 6y squared. Are those like terms? Yes, they both have a y squared. Okay, so then you just add or subtract their coefficients. So what's negative 23 plus 6? So the final solution is negative 17 y squared. You keep the exact same variable. When you're adding and subtracting, you just keep the same variable. All right, then they start throwing more variables at us, but if they have the exact same amount of A's and the exact same amount of C's, then they're like terms. Okay, so do you think 2AC and 9AC are like terms? Yep, and it says just to add them together. So what's 2AC plus 9AC? 11AC. Yeah, you do not make it an A squared and a C squared when you're adding and subtracting, okay? When you're adding and subtracting, you just keep it the same variable as it already is. All right, number 4. Negative 25x to the 4th y squared minus 25x to the 4th y squared. Are those like terms? Yeah, they have the same amount of x's and the same amount of y's. So they are like terms. What's negative 25 minus 25? Negative 50 x to the 4th y squared. You keep the variables the same. Any questions so far? All right, so now we're going to start seeing some more things added in, some of which may or may not be like terms. Okay, and I'll start blending it. So write down number 5, please. 3y plus 9m plus 6y minus 2m. So we leave everything alone except what's underneath the radical. What's 49 plus 72? 121. Is 121 a perfect square? So do we have some like terms we can simplify with on number 5? Yeah, I got y's and m's, right? Right. So it doesn't matter technically if you do your y's or m's first. So I'm just going to do my y's because I had a y first. What's 3y plus 6y? 9y. And in my m's, I have a positive 9m minus 2m. What is positive 9m plus minus 2m? Positive or negative? So you need to put a plus 7m. Yeah, then you can't do anything else because these are not like terms. That's right. Because I have a y and an m left, and those are not like terms. Now, is it okay if it's reversed and it says 7m plus 9y? Yes. Okay. Same thing mathematically. All right, number 6, we have 12b plus 8a minus 10b. Can I simplify anything there? Yes. What? 12b minus 10b. The b's, right? What is 12b minus 10b? 2b. What do we do with 8a? Do I just ignore it? No, you got to keep it with your solution, okay? You can't just leave it off because it didn't have a like term. Just bring it on down, okay? We good? It's getting there. We're just combining like terms. This is old school stuff. It's not old school, but stuff I've done before. I mean, we're gonna lie about it, but we signed up for honors class. It don't matter. It's Algebra 1. You just have to do it anyway. At least you didn't have to do it all year. That's the bonus. All right, 13w squared plus 9w minus 4w squared plus 11w. Are all of those w's like terms? No. Which ones are like terms with which? The squares are like terms with squares, and the plain w's are like terms with the plain w's, right? Okay. So I'm just going to do them in decreasing order. That means highest to lowest exponent. So I'm going to start with my squares. What is 13w squared minus 4w squared? 9w squared. And then I'm going to do my w's. What is positive 9w plus 11w? And that's positive, so I'm going to say plus 20w. So if you combine it and it's a negative, you need to put a minus. If I were to combine that and get negative 20w, you have to put minus 20w. Oh, they're so quiet. They're scared. Okay. Look at number 8 carefully. Do you see the difference on those variables? What's the difference? Right. So are all 3 of them like terms? No, because this one has an m squared and one n. This one has a 1m and an n squared. And this one is an m squared and one n. So these two are like terms. Y'all agree? So what is 10m squared n minus m squared n? 9m squared n And then that means the 7m squared does not have a like term, buddy, so you just copy it. Is that okay with everybody? Any questions on combining like terms so far? You try those. And yes, they're easy. Bitty baby. And we're going to get in some exponent rules next.
Zero is just 0. Does that make sense? What's 0 squared?
Takes you longer to write the problem than to answer it.
Negative 4 times 3. And negative 12 times negative 12. Positive 144. And then 2 times 3. 6. So x equals 0 plus or minus square root. What's 0 plus 144? 144. We've already taken the square root of 144. What is it? 12. So y'all, what this means, your two solutions here are positive 12 over 6 and negative 12 over 6. What's 12 over 6? 2. What's negative 12 over 6? Negative 2. So another way your solutions can be written is plus or minus 2. Do we do that? And you don't have to put that together at the end, but just understand if you see them written that way.
All right, what's answer number 9? Negative 11 CD squared. Raise your hand if you got that one right. What's the answer to number 10? Negative 6a. Raise your hand if you got that one right. Any questions? All right. Now we're going to start learning our exponent rules. All right. You know that when we have a power, well, let's just do it like, do it easy one.
Now doing this, move everything to the left.
The big number on the bottom, y'all know what that's called? That's called the base. The big number on the bottom is called the base, triple B. The little number on top is called the exponent, right? Now, the exponent tells you how many times you multiply the base times itself, right? So that means 5 squared means I do 5 times 5, correct? 2 5s. Multiply 2 5s together. If the exponent was 3, or let's just go ahead and make it 4, I multiply it 4 times. Correct? Here's my filler word. All right. So, yeah, the exponent tells you how many times you will multiply the base times itself. So, exponent rules, the first one and the most simple one is when we multiply monomials, we add the exponents on like bases. What do you think that means, like bases? Bases that are the same. So 2 x's are like bases, right? Right? Or 2 y's would be like bases. So this is easy as pie, y'all. X squared times x to the 5th power. Now, can I tell y'all a pet peeve? If your math teachers before me let you get away with this, I'm sorry, but it's mathematically incorrect. Don't call any names. I don't want to know. Okay? Never call this x2 and never call this x5. That is mathematically incorrect. Because you know what x2 means? 2x. And you know what x5 means? 5x. Which is not the same thing as x to the 5th power, is it? No. Now, if you say x to the 5th, that's okay. You don't have to say the word power, but you can't say x5. You'll hear me go, If you say it, I'm going to say, Okay? You ever play the game Taboo? If you say a wrong word, you get buzzed. I'm going to buzz you if you say that. It's mathematically incorrect. Okay? So x squared times x to the 5th power, we're multiplying 2 monomials. That's a monomial, that's a monomial. They have the same base. Right? What's the rule say to do? Add the exponents. What's 2 plus 5? 7. So the answer is x to the 7th power. That's it. Easy peasy, y'all. Just wait. Y'all just wait. So number 12, w to the 7th power times w to the 4th. What do you think the answer is? W to the 11th. You multiply two things that have the same base, then you add the exponents. One of my numbers got erased. See, look, it gets more fun. Okay, now sometimes you'll see the dots, and sometimes you just see parentheses. Or sometimes you see dots without parentheses. Okay, your homework, I think, mainly uses, well, it uses both. I ain't gonna lie. It uses dots and sometimes it uses parentheses. Okay, so are we okay with the first two? You just add the exponents. All right, number 13. 4x squared times 3x to the 5th. 4x squared times 3x to the 5th. Now, what do you think you do with those coefficients? The numbers are kind of variables. You just multiply them. What's 4 times 3? 12. So the numbers you just multiply together. And then what do you do with the x's? They're multiplying, right? They're both x's, so you just add the exponents. So square plus 5th power is x to the 7th power, and that's it. It looks scarier than it is. You okay with that? Just wait. I'm going to throw some friendly fractions in there in a minute. Cannot wait. Cannot wait. I'm so excited about it, actually. All right, so this next one we have 6xy times 2y squared. 6xy times 2y squared. First things first, what do you think we're going to do first? Multiply your coefficients, right? Right? What is 6 times 2? 12. Yeah, the numbers you just multiply together. Those are not exponents, they're just numbers you multiply. Okay? Does x have a like base, buddy? No. So you just put an x in there. You can't leave it out. Now, question. I got a y and a y squared, right? Those are like bases, aren't they? What's the exponent on this y? It's a 1. If you don't see an exponent on something, it's an understood 1. Okay? So when I multiply my y's, I add 1 plus 2. What is 1 plus 2? 3. Y to the 3. Y to the 3rd power. Y'all see that? Y'all see how we did all that? I multiplied 6 times 2. X didn't have a buddy, brought it down, added my y's. If it don't have an exponent, you put a 1 on it. Okay? This is supposed to be number 15, and somehow my number got erased. Sorry. That doesn't mean we skip it. Never, ever, ever. All right, this one says negative 4a cubed b times 3a squared b to the 5th. Negative 4a cubed b times 3a squared b to the 5th. Y'all know when I say cube, that means 3rd power, right? Square is 2nd power, cube is 3rd power. It's just the 5th power. We don't have a special name. All right. So first I multiply my coefficients. What's negative 4 times 3? Negative 12. And then I've got a's. So what do I do with these a's? Add the exponent. What's a 3 plus 2? A to the 5th power. And what the heck? Did y'all see my stuff just disappear? Undo button. What the heck? Okay. I have no idea what's happening.
So, yeah, it's total something.
No, you've got to do it, y'all. 12a to the 5th. And what do I get when I add my b's? That was a b to the 1st. 6. Negative 12. Whew, I don't know what that's going up. Okay, there you go. Y'all had it copied, didn't you? What?
It just has 3A.
I know, but y'all's is on your paper. I don't know what's happening. This is a crazy thing. Oh, Lord, help us, Jesus. Okay, number 16. Y'all copy that before it magically disappears. 8x to the 4th y squared times negative 3x to the 4th y to the 9th. So what are we going to multiply first?
8 times negative 3.
What is 8 times negative 3? Negative 24. And then I multiply my x's, and that means I add them and get x to the 8. Same thing with my y's and get y to the 11. Maybe it was just that one. I don't know. How's that one? Is that okay? Number 17. How many monomials do we see on number 17? There's 3 of them, right? And this time it's separated by dots instead of parentheses. That's okay. Sometimes it's dots, sometimes it's parentheses, sometimes it's both. So we got 6m times 7m squared n times n to the 4th. Yep, do all your coefficients first. I know what I was talking about when I say coefficients, right? The numbers in front of variables. So 6 times 7 is 42. And then we'll add my m's. I got an m to the first and an m squared. I add that and I get m to the what? M to the 3rd. And then I add my n's and get n to the what? 5th. This isn't so bad, is it? I mean, like, there's not, you can't even show work on it. I mean, it's that easy. Just wait. Do what? Until you have to. We've done 18 problems, hadn't had to show work yet. No, it's not. Quit crying over a fraction. I will make you do it 4 times. All right. What do we do first on number 18? It looks a little weird. Just multiply, right? What are we going to multiply first on number 18? The numbers, right. Negative 4 times negative 5. A negative times a negative is a what? Positive. So that's positive 20. Y'all agree? And then you just do your R's and S's. What are we going to get for R? There's 1 plus 4 is 5. Yeah, R the 5th. I don't like my S's in there, especially with 5s. I really don't like S's. And then S squared and S to the 1st makes S to the 3rd. Yeah, I hate S's. Yeah, that one was a 5, but these are S's. I apologize. I don't like S's for variables at all. I did. And my B's look like 6s too, so I don't like those either.
I don't like when M and N is beside each other because I often just like glance at a problem.
And you're just like a bunch of, yeah.
It just looks like.
Gotcha. All right, look at 19. 1/4 times 8mn times negative 6m squared n squared. We're going to do this in our head, y'all. We're going to multiply all our numbers 1/4 times 8 times negative 6. Take care of this first. 2. That's 2. Is that hard? No. And then it's just 2 times negative 6. What's 2 times negative 6? Negative 12. And then you do all your m's and n's. Right? What do I get when I add my m's? M to the 3rd. Somebody said M3. M to the 3rd. And what do I get when I add my n's? N to the 3rd or n cubed. Very good. See, that fraction did not get scary, did it? So the rule we just learned is when we multiply 2 things that have the same base, we add the exponents. Look at number 20. What's number 20 doing to us? Oh, we got to multiply over here, right? And then we're going to add. Why are we going to multiply before we add? Yeah, order of operation says you multiply and divide before you add and subtract. Correct? All right. So yeah, so this means multiplication over here, so I'm going to do that first. So I'm going to copy that 2x to the 5th y squared because I'm not doing anything with it just yet. And copy that plus sign. All right, then I'm going to ignore all this stuff and then multiply this like we've been doing. So what about for my numbers? Just 3, isn't it? 3 times 1 technically, which is just 3. Y'all agree? And then x to the 6th power, y to the 5th power. Are these like terms? Are these like terms?
No, because they're on the same.
The x's don't have the same exponents or the y's, right? So if they don't have the exact same exponents on the exact same variables, then you can't simplify anymore, so that one's simplified. Y'all with me? They have to have exact same exponents for them to be like terms. So since they're not like terms, I can't do anything else to simplify, so I'll leave it alone. Got it? Do what? You're confused?
Yeah.
You know what like terms means?
So we need to just give it squares in the way.
In a minute. All right. So these are not like terms because the x's are not the same.
Yeah,
He's confused because that's what we did up top. But up top we was like,
Yeah, we multiply this part, and then you have a plus sign, so it's back to combining like terms. Yeah, you're multiplying right here, and you were multiplying all up here. There's no pluses and minuses up here for a while. You see that? But when they put a plus sign, we go back to combining like terms. Well, I don't have like terms. Does that make sense? So you need to know the difference if you're multiplying or adding and subtracting. All right? All right. This one. Copy that down first. Yeah. We're going to learn another exponent rule next.
we have to round, and we're gonna round this time to the nearest thousand. Where's the thousandth place?
Sorry.
It is a decimal, okay? Yes. It's the quarter number to. Yes? Okay. All right, so x squared plus 4x plus 1 equals 0.
So what are we going to do first here?
Yes. Now we need to identify.
I'm going to multiply over here, right? And then I'm going to multiply over here. And then I'm going to put a minus sign in the middle. And if they come out to be like terms, I'll subtract them. Y'all with me? Y'all see that? If this is multiplication and this is multiplication and we multiply before we subtract according to order of operations. All right. So let's do these first 2 monomials. What's negative 5 times negative 3? 15. Positive 15. What's c times c to the 4th? C to the 5th. And what's d times d? D squared. All right. Copy my minus sign. And these are going to be kind of spaced out, but that's okay. All right. Now I'm going to multiply these 2 monomials. What's 7 times 2? 14. What's c squared times c cubed? C to the 5th. C to the 5th. And then d squared is just d squared, right? Okay. Are these 2 like terms? Yes, they both have a c to the 5th and a d squared. So I can combine like terms. What's 15 minus 14? 1. So you can put the 1 or you can leave 1 off and just say c to the 5th d squared. So you can put the 1 on the front or you don't have to. Okay? Got it? I'll put the 1 there in case it confuses you. If it don't confuse you, leave it off. And that's seriously as hard as it gets. You multiply a little, and if they're like terms, you add or subtract depending on what sign you got in between.
That's the hardest we get today.
The hardest on multiplying. Okay, so let's recap. Okay, y'all, I don't have an eraser. I've lost my one and only eraser. Yeah, my good one. The one that's like a squeegee. I'm really sad about it. I don't know where it is. I lost it last week. So now I got my pretend eraser.
Oh my.
I know, Amazon needs to be my friend. All right, I know. So there's the exponent rules. When we multiply 2 things that would have the same base, we add the exponents, right? Okay. We're going to learn another exponent rule right now. It's called a power of a power. Write that down. Power of a power. Power of a power. Now, y'all understand what I'm talking about when I say power of a power? If I take something that already has an exponent on it, that's a power, right? Okay? So power of a power, I take it and raise it to another exponent. So power of a power, I take something that already has an exponent and then I raise it to another exponent. Okay? That's what it means by power of a power. Now, when you have a power of a power, you're going to multiply the exponents together. You're going to see these with parentheses. So you will always have parentheses when you do a power of a power. Okay? So you've got to keep all of your exponent rules separated. You got to know when you're going to add the exponents, and you got to know when you multiply the exponents. And tomorrow we're going to learn that sometimes you subtract the exponents. All right? So you got to know all of your exponent rules, and we're going to end up having 5 exponent rules. 5 total. We're doing 2 today. We'll do the other 3 tomorrow. All right. Power of a power. X squared to the 5th power. Y'all see that? X squared is a power. I raise it to another power. Y'all see that? What's the rule say to do? Multiply. What's 2 times 5? 10. So the answer is x to the 10th. Okay? It's just x to the 10th. Now notice on number 23, there's more than one thing in the parentheses. Y'all see that? Okay, y'all listen to me. If there's more than one thing in the parentheses, everything gets the power. I've got the power. Okay. Yeah, okay. They ain't the only one that can sing. Come on. All right. Everything gets the power. Right? The 2 gets the power, even though it's a number, not a variable. The x gets the power and the y gets the power. Everything gets the power. Okay? Now, if it doesn't have a power on it, what's its power? 1. Right? I told you, if it don't have an exponent, it has a 1 on it. So if it helps you, the 2 gets a 1 and the y gets a 1. Right? Okay? And the rule is, power of a power, you multiply. So that's going to be 2 to the, what's 1 times 5? 5. 2 to the 5th, right? And then 2 times 5, I multiply that and get x to the 10th. And then y, 1 times 5 is y to the 5th. So instead of writing those ones there, you just remember that if it doesn't have a power, you give it the outside exponent, then that'll be good too. That'll save you some time, right? I'm just showing you why it works that way. And then you simplify. And the only thing we can simplify is 2 to the 5th power. What's 2 to the 5th power? 32. Do y'all know how to do a power in your calculator? Let me get my calculator. It might take a second. Hang on. Where is my calculator? Now, you don't want to sit there and hit 2 times 2 times 2 5 times because that takes a long time. I don't know what's in my screen. All right. So you put your base, which was 2, right? And then you have above the division key, you have something I call the rooftop button. That gives you an exponent. Okay, so above the division key, hit that, and hit 5, and hit enter, and it'll tell you 2 to the 5th power is 32. Okay? You're just waking up. It took a nice long weekend, a siesta. Okay. Okay. Maybe you'll wake up in a minute. All right. So the only thing we simplify here is that 2 to the 5th power. We change it to 32, and then leave your variables alone. Okay? So evaluate your numbers. Now I want you to evaluate the numbers unless it's like over like a billion or something. If your calculator runs out of digits, then don't write it down. Does that make sense? Okay? Then you could just leave it 2 to the 5th or whatever. Look at number 24. We don't have a ton more examples if y'all are just wondering. I think we're going to like 28 or 29. We won't even hit 30 examples. Dang it.
So wait, so there's not like another twist after this, like this again?
We're going to combine it with the other rules, and that's it. Okay, so number 24, power of a power. And I know it's power of a power because I see parentheses and I have an exponent outside the parentheses. Okay, that's how you know it's power of a power. If you see parentheses and there's an exponent outside the parentheses. Okay, so everything inside the parentheses gets the exponent. Y'all with me? So -3 gets a third power. X gets what's power? Try again. Power of power. We multiply. 2 times 3 is 6. And Y gets what power? Third. So if it already has a power, you multiply. Y'all with me? And everything else gets the outside power. And then lastly, we evaluate -3 to the third power. Now, if you're putting that in your calculator, you need to use parentheses. What is it? Well, 3 negatives multiplied together is going to be a what?
Negative. Negative.
An odd number of negatives is a negative, right? Negative what number?
-27.
If you do an even one, you have to use parentheses. Odds will work, but evens will lie to you. Yeah. Calculators lie if you don't put it in correctly. So that's going to be -27, x to the 6, y to the 3rd. So that means you got to know your multiplication rules. An even number of negatives should be a positive. An odd number of negatives stays negative. Right? Okay. Copy down 25. That's the power of a power, isn't it? How do you know 25 is a power of a power? Parentheses with the exponent outside. And that means everything on the inside gets what power?
3.
A 3. And if it already has a power, what do we do with them? Multiply. So that means I'm going to have 1/2 to what power? Third. No, it's not 1.5. That's 3 times a half, but it's not 1/2 to the third power. So what's A going to be? A to what power? 9. B to what power? 12. C to what power? 15. And so now we just have to evaluate 1/2 to the third power. If you tell me a decimal, I'm going to mark it wrong with my red pen. They did not give you a decimal. Don't you give me a decimal. Y'all, what's 1/3 to the 1/2 to the third power mean? 1/2 times 1/2 times 1/2, right? It is 1/8. It's not 1 1/2. Not even close. You're not adding, honey. You're exponentiating. That's a fun word. Go tell that to your mama. She'll think you learned something good today. What'd you do in math class? I exponentiated. Y'all understand why it's 1/8? It's a half times a half times a half. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. Fractions aren't scary. Look at number 26. What's going on in number 26? All right. So what do you think you're going to do first? Power, power, multiply. Yeah, exponents come before multiplication. Please excuse my dear Sally, right? Right? And power, power is technically exponents. So a power, power over here, and a power, power over here, and then I multiply them together, which means I add the exponents on the like basis, right? All right, y'all copy number 26. Bless you. All right, powers of powers. So the first Hello, YouTube. That on TikTok, right? Okay. So everything in this parentheses is getting an extra square, right? Right? If it doesn't have an exponent, it gets a square. If it already has one, I multiply it times 2, right? So negative 2 is going to have what exponent? A 2. A is going to get a 2, and B is going to get a what? 4. I'm going to go ahead and do the other one too. So the next one, everything is getting a square in this parentheses as well, right? So 3 gets a what? A gets a what? 4, and B gets a what? 1 times 2 is 2. Don't worry about it. Let me worry about it. All right. So next, I'm going to fix my numbers. Can I combine some steps here? Is that okay with y'all if I can combine some steps? Okay. So I'm going to fix my numbers. What's negative 2 squared? Is it 4 or negative 4? My calculator gets negative 4. We have to know that a negative squared is positive, right? Your calculator does lie if you don't use parentheses. You got to know it. So that's positive 4. Let me go ahead and do this. What's 3 squared? 9. And what's 4 times 9? 36. Y'all with me? So I just did my numbers, finished them out. Now I'm going to do my A's. Now what's happening in between? Multiplying. What was the rule for multiplying? We're back to add. Okay? So what's A squared times A to the 4th? Add those and get A to the 6. Very good. Y'all see what I mean by having to keep your rules straight? And then B to the 4th times B squared is B to the 6. Okay? So at first I was doing power of power, so I had to multiply my powers. And then I went back to multiplying with my exponents, which means I had to add my powers. Does that make sense? Power of a power, you multiply. Power times power, you add. All right, y'all copy 27. Copy 27. 6a squared b all cubed times 1/3 abc all squared. I know. Talented.
So here we're gonna have a single 7.
That's my talent, and I can say math really fast. But sometimes I stutter. Can't say parentheses.
So when you type these in,
All right. So what's the game plan for number 27? Power over power over here, and then power over power over here, and then I multiply them together, correct? Correct? Okay, so first parentheses. 6 gets what power? 3rd. A gets what power? 6, and B gets what power? Everybody okay with that one? They already had a power, we multiplied. All right, second parentheses. 1/3 gets what power? A square. A gets what power? B gets, and everybody gets a square, right? They were all ones to start with. All right, I'm going to work on my numbers. What's 6 to the 3rd power? 216? Calculators help us, right? What's a third squared? Yeah, 1 over 3 times 1 over 3 equals 1 over 9, right? Multiply those two. I'm going to use my calculator. Look at me doing my calculator. 216. Oh, I did not do that. Clear that. Yeah, I know. 216 parentheses 1 divided by 9. Hit enter. 24. Yeah, parentheses 1 divided by 9. I did without saying that's what I was doing. Did y'all catch that? Caleb called it. Parentheses, and then you're dividing. That's it. So 24, and then what are we doing with our A's, B's, and Z's over here. What's happening here? You're multiplying, so we're adding the exponent. So a to the 6 times a squared is a to the 8. B to the 3rd times b squared is b to the, and then I need to tack on a c squared, right? So 24, a to the 8th, b to the 5th, c squared. That 9 is in my way. It does look like that. Let me move that 1/9 over here. Sorry about that. I should have skipped a line. So that's not terrible, is it? Anybody like completely like lost out and see? I need to throw a life raft to anybody. You just gotta keep your rules straight. You're a motorboat, a yacht, a yacht. All right, these are my last 2 examples, friends. No lie. But look what they throw in here at us now. We adding, aren't we? But look over here. What are we doing out here? Power and power. What are we doing over here? We're multiplying, right? There's no power over here because there's not any outside exponent, so it's multiplying. I'll say that. And then we go back and add if we have like terms. Just throw it all together. This is the hardest thing we'll do all day is when they throw it all together. Y'all are waiting patiently. So power of a power. Let's start with that. 2a squared all to the 3rd. So that's going to be 2 to the 3rd and a to the 6. 2 times 3 is 6. Y'all with me there? And I'm going to go ahead and fix that. 2 to the 3rd power is what? 8. So that is just 8 a to the 6th power. Y'all okay with that? Okay. I'm just going to copy these plus signs down here and then roll with it. So right here we're just multiplying, correct? And all we can do then is add my exponents on my a's. 3 times 1 is just 3. And that's going to be a to what power? You add them, so it's a to the 6. I'm going to drag that all the way down so that they're on level rows. Are those like terms? What do I get when I combine them? 11 a to the 6. That's it. Simplified. Questions? Is that terrible? That ain't terrible. Not too terrible. Okay, number 29. What's happening on 29? A power of a power right here. And I also got a power of a power over here, right? And then after this power of power, I got to multiply times this monomial, right? And if they're like terms, I finally subtract. Y'all with me? Okay. So it's good. Huh? 20.
Whoa, 20 of them.
No, I'm talking about those.
I don't know. I'm not stopping to count right now. You'll get your paper in 5 minutes or less. All right. Oh, you're going to time me. Okay. See how it is? I'll take that clock off the wall. All right. Power and power right here. Okay? So everything in this parentheses gets what power? A 4th power. Unless it already has one, then we multiply times 4, right? So it's going to be 3 to the 4th, x to the, and y to the 4th. Minus, let's do the next parentheses with power of power. Everything in this parentheses gets a square, right? So 7 squared, x to the 10th, y squared, and I'm just going to copy the rest of it. All right, now I'm going to simplify my numbers for sure. What's 3 to the 4th power? 9 times 9 is 81. Y'all with me there? I'm just going to copy that for right now. Minus, what is 7 squared? 49. And I'm going to go ahead and add my x's and y's because they're multiplied here. What's x to the 10 times x squared? X to the 12. And what's y squared times y squared? Y to the 4th. Are y'all okay with how I've done all that so far? What is that calendar doing? Popping up there. All right. So So finally, are these like terms? Yes. So coefficients. What's 81 minus 49? 32. And then copy my variables. When you combine like terms, you do not change the variables. And there's your final answer. So if these were not like terms, would I combine them? No, if they didn't have the exact same exponents, I would not combine them there. You just leave it alone. All right? How did I get 12? Right here?
I added the x's, and then I added the y's, because that was multiplied right there.
Any other questions? All right, that is the end of notes for today. Y'all just want to hear me stutter. That is so sad.